So as I wrote here, first, energy efficiency. We want to reduce our demand as much as possible, but of course it also has a cost impact. You can build a building envelope so that you use as little as possible energy. But for example, when you have a local a potential or possibility for a local district heating system which is fed by agricultural residues, then it would perhaps make more sense to connect to the district heating system and use this renewable local resource as compared to invest hundreds of thousands of euros to build the perfect building which utilizes as little as possible energy. So there is also a cost balance of implementing energy efficiency solution. But most of the energy efficiency solutions are pay off in a certain period, in a 1 year or even a few months or 3 to 5 year period. And then when we have done as much as we can on reducing our energy demand, then we look at renewable energy solutions. Again, when we look at the building, which I think most of us are most familiar with, heating and ventilation, air conditioning uses about 60%, depending on which climate you live. But I think about 60% of the building energy use is going into heating and cooling to create a comfortable atmosphere here. Mike, sorry, we said we should switch off the AC here because it could affect the microphone. Is it affecting it or are you okay with it? Okay, good. It makes quite a noise here. Okay. And then the second biggest user usually in a building is hot water, so about 20%, and it depends a lot on the behavior of building inhabitants. If you have some teenagers who shower like 20 minutes in the morning, I have no idea what they are doing there, but it takes 20 minutes. So that can, of course, impact not only your water consumption. Water is also costly, of course, but hot water, and that hot water needs, of course, energy to produce it. Cooking, cooling, like refrigeration and a freezer. All of us have one at home, I think. If you have a very old one, of course, it consumes more electricity than the new A++ rated ones. Lighting. I think especially in lighting we have a new technology called LED. The LED lights are really amazing. They are also now have dropped a lot in their prices, and I think most of us can really invest a few euros and replace all the light bulbs and save some of the electricity there. More and more like gadgets like our phones and similar other gadgets, of course, draw also on your electricity consumption and create more and more consumption, entertainment and communication. I put transport here in the bracket because so far it has not been included in the building system, but as soon as we invest into an electric chargeable vehicle and we charge it through the electricity system from our house, then of course it becomes more or less part of the building energy system. And when we think about the option, what we call vehicle to grid, that the stored energy in the car can also be fed back into the grid. Then we have the transport sector as a storage for electricity into the grid, and we could use the energy stored in the battery for cooking in the evening or something like that, yeah? To reduce our peak usage from the electricity. In most civilized countries we have building regulations. We cannot just build as we want. We have building regulations even in Ireland, of course, yeah, very important. And I was actually amazed that yeah, that you have come already so far to implement the European directives for
We're doing pretty well.
yeah, really, I was surprised. Yeah. So you are ahead. You are ahead of Sweden. You are ahead of Sweden. That's yeah. So, but what does part L tells us? I think there are two important parts. The one is the U value, which we will see in the next slide. But the specific energy use, we want to reduce the kilowatt hours per square meter per year what the building uses, and European Union talks about the NCEP, the near zero energy building. And we are approaching it. We have, like in the 1990 building regulations, the building standards like prescribe, when we implement the building standards, we would use about 200 kilowatt hours per square meter per year. The buildings before that perhaps have used 250 or 300 kilowatt hours per square meter per year. So step by step we have improved, and all countries of course have done that. And the latest one, which is going to be, I think, from 1st of April, isn't it? The 2018 like update is to be followed from 1st of April 2019, as much as I understand. And you see, it tries to reduce the specific energy use in a building, kilowatt hours per square meter per year, by 70% from the 2005 levels. So it's quite a big step. We are now between 40 and 50 kilowatt hours per square meter per year when you build a new building from 1st of April 2019. And I'm not quite sure how what it says about renovation of buildings. Like usually when you do bigger renovations, you're also obliged to follow the building standards. Yeah, it is like that. Yeah. So when you extend your building, then you will have to make sure that the extensions are built according to the latest standards. So we have the U values, what I think the engineers here who have worked with buildings know what that is. It describes the heat loss through a building part in watts per square meter, and Kelvin, which is also a unit for temperature. And this was, I put here in the column the prescriptions for 2008. So already from 2008 to 2011, it dropped from 25 to 21. They allowed heat loss through a wall, in this case through the floor, through a wall, or through the windows. Yeah. Windows have much higher losses because we only have like a little bit of glass and not a thick wall with insulation. And then we have now this Part L, which is to be complied to from 1st of April 2019, when I have the right information there. It implements the Energy Performance of Buildings Directive from European Union and the requirements for the near zero energy buildings. And what does that mean in U values? We have again a drop of about I think 20% or 30% from 0.21 to 0.18 for floors, and for the wall, same for the walls, and also an improvement requirement for windows.
I think that's just for commercials. It's not for domestics yet, is it?
No, just commercial.
Just commercial, yeah. This
Yeah.
particular deadline is just for commercial buildings.
The 1st of April.
It's not for domestics yet, sure it's not.
Yeah.
I'll check that, but I think it is actually.
It is for domestics as well?
Yeah.
I hope it is. I thought it was only for commercial buildings.
Yeah. I think in Sweden is, I think, the 1 year or 2 years for public buildings, and then all other buildings after 2020. Yeah.
Okay.
But I'm not sure. Yeah. So of course that means that all the building industry, those who produce windows, insulation, etc., have to adapt to it and offer the products which will be able to fulfill these U values. And then we have another important part in the Part L. We know that 40 to 50 kilowatt hours per square meter per year, that's the target, that's the goal of the standard. And 20% of this consumption in the building should be supplied by renewable energy. So the renewable energy ratio of 20%, that's the maximum. I think there is also flexibility from 10 to 20% in different cases. But that means that about 10 kilowatt hours per square meter per year should be contributed for heating now from renewable energy sources. And that could be a solar thermal system, for example, or a biomass solar thermal system, or biomass stoves, wood pellets or wood chips boilers, and also heat pumps. Yeah? So these are acceptable technologies which are listed, but of course there are also other technologies. I think these two parts are very important to keep in mind. The U value, how much do we lose through the building envelope? So we have to adhere to that by choosing the right products and building envelope when we design new buildings or when we renovate. And then also to look at, okay, how can we fulfill this requirement of 20% renewable energy? Or we can, of course, go beyond the 20%. Yeah, that's not forbidden, but 20% is the is the minimum what we should achieve. Yeah.
Just to confirm, they've come into force, so any house that is getting planning permission from the 1st of April will have to comply with the...
Domestic as well?
Yeah.
Excellent.
Yeah.
Excellent.
Okay, that's good.
Yeah.
So, as said, that applies to new buildings and to big renovations. But if you don't have plans to renovate on a larger scale, there are a lot of options to improve or reduce your energy use in the building. And we always start talking about these so-called low-hanging fruits, which are in the different sectors. In heating, for example, to have better temperature control. We know that about like heating in winter, when you have 23, 24 degrees, very comfortable, very cozy, you can sit around in your underpants, but but it's not very efficient. You will spend much more on your electricity bill or other energy bill. So if you are able to reduce your indoor temperature by 3 degrees, then the energy saving would be about 10%.
Put on your thermal.
Yeah, exactly. Put on a sweater or something like that. Yeah? Or use these cozy blankets. You have so nice wool here in Ireland. I think buy a blanket, and that would be the best investment you can make to save some energy. Ventilation, open doors and windows. Yeah. We have done some studies in an elderly home where the owner complained that energy use was so extreme, and he didn't know why. Of course, elderly people, they don't move so much. They have other levels of comfort they need. Of course, higher temperatures as compared to a student home or something like that. But then we found out that many of the older people, or some of the older people, had a cat, and the cat wanted to be on the balcony. Yeah. Sometimes, and the balcony door was open the whole day, yeah, so that the cat can go inside, outside. Yeah. So behavior is of course affecting energy use. Yeah. So things like that, of course, affect energy use. Hot water. How long do we shower? We have already mentioned that. Sometimes we find these old water boilers which have no possibility to set the temperature. And they are set to the maximum, and the maximum is like boiling hot. Yeah? If you have perhaps I don't know, what is the standard in Ireland in a family home? The size of the boiler, 80 liters, 200 liters, 300 liters? Or?
You mean the tank?
The tank, yeah, the hot water tank.
150, 200
Yeah,
liters?
yeah, okay. So if you are 2 or 3 or 4 people in the household, perhaps you don't need this tank heated to 90 degrees. It's enough to have it on 60 or 70, and that would also reduce your energy consumption for hot water. And then, not sure, is there a night tariff in Ireland? So the hot water production could be put on the night tariff. It's probably done. I don't know. It was available in Sweden before, but it's not available anymore, and they are thinking about reintroducing it because we have this problem of peak electricity demand during winter period.
You have to pay for 2 meters.
Yeah, okay.
Storage heating.
Yeah, so that actually does not reduce your energy consumption, but your electricity bill if you don't have these 2 meters. Yeah. And of course, the pipes, are they insulated? And then also water-saving shower heads and taps are part of like low-hanging fruits, low investments. But the problem is when you put the shower heads and taps on a pipe which is very badly insulated, you will wait very long until hot water comes. Like in rooms like this, in commercial buildings, we often find lights on the whole day, but with a simple like installation of a sensor, of course that can be avoided on public toilets, etc., etc. Replaced by LEDs. Refrigeration, I mentioned already, replace it. If you have a 20-year-old fridge, it's time to replace it, even if perhaps lasts 5 more years, but it's better to get rid of it. And then electronic equipment, don't use standby, switch it off. Of course, the equipment becomes better. There is this 1 watt program in European Union which tries to force the industry that the standby consumption shouldn't be more than like 1 watt of a TV or so. So then it doesn't make much sense anymore. But I think most of the older TVs, sets or computers, laptops should be switched off. And then when you have done all the low-hanging fruits, then you can start thinking about what solutions are useful to implement but cost a little bit more money. Insulation, start with the roof, the walls, replacing windows, floor insulation, etc. And then think about the heating system. What of the heating system need to be replaced or can be complemented? Like air-to-air heat pumps, for example, are very effective, at least for temperatures above like -5 degrees. They will save you a lot of energy, electricity costs if you have electric heating. Replacing your old heating systems. And then ground source heat pump is when you think about heat pump and want to invest more. What are the current prices in Sweden? It would cost between 10 and 15,000 euros to install a ground source heat pump. In Ireland, probably same range. Yeah. So.
But air-to-air and air-to-water are much more cheaper, aren't they?
Well, if you look at, typically they come out as a package with heating controls, some new radiators, and that kind of stuff.
So it brings
It's
it up.
10, around 10 or 12, I would say.
Okay.
There'd be good grants for that though. Would that be,
Close to 4,000 euros.
Okay.
Grants.
Yeah.
Right.
So when we put all this together, we can call it the megawatt power station. It starts with saving of hot water. These shower heads can save 50% of your costs for water and hot water heating. Temperature controls, I think, very important to ensure that you have the right temperature in the right room. You shouldn't have the same temperature in the sleeping room as you have in the living room. I think that makes sense. Another option, like window ceilings, which we haven't mentioned yet, instead of throwing out your old windows, if you don't have the money. Also, perhaps putting window ceilings in can also be an option and reduce like that. Yeah, all this like low-hanging fruits can perhaps save about 20% of your energy consumption today.
That's a lot.
Yeah.
Yeah, it is.
Yeah.
It's huge.
Yeah. It's a lot can be done with behavior change as well. Yeah? When I moved to Sweden from South Africa, in South Africa energy costs were really high, and we were really used to save energy, and we also have experienced blackouts and load shedding, what is called. So we moved to Sweden, in a country where electricity supply is plenty, electricity is cheap, and we move into our house 5 people. And we know that the previous owner had 3 people in the house, and of course from like the digital times we are living in, we know the electricity consumption from the owner before. And we haven't changed anything in the house except the light bulbs. But we have, in the first year, we have used only 2/3 of the energy what the previous owner has used.
Wow.
Because I think the main reason was the temperature, the room temperature, between 19 and 20 degrees instead of 23. We are not using the tumble dryer. Yeah? We are using sun. Yeah? And things like that. I think our behavior can change a lot. Yeah? In spite of having teenagers which shower 20 minutes. Yeah. So 20% is not so far out of the world. It can be done. So and when we think about cooperative work together, we test methods, we share experiences. Perhaps we can organize ourselves to buy services and materials together, and we should also measure results and compare with each other. There are some apps. Most of us have a smartphone these days, of course, and there are apps available which, what they call gamified, is like competition. How much energy am I using as compared to my neighbor? So I have just got one recently, and it is very nicely designed. It shows you can enter your house, your heating system, your heating technology, your size of the house, etc. And then the app compares similar houses in the neighborhood and shows you, okay, how much you are using, how much the others are using. Yeah? So
Who's in their underpants? Who's not in their underpants?
yeah. Okay, so we are saving money by using and losing less energy, yeah, at the end of the day. Just touching quickly on the renewable energy solutions before we break. Solar thermal on the rooftop. Commercial buildings and private homes, of course, benefit from it for hot water production, but also for integrated into the heating system. And then we can have a boiler here, which is either additionally heated with electricity or with pellets, or even a heat pump can be connected here. Then we have an integrated heating system. Biomass, a pellets stove, larger pellets, or a small local district heating system. Heat pumps, we have the most simple and cheap solution, but could be, in many cases, could be very, or could be the only solution, because replacing the whole heating system is a huge investment, 10 to 15 to 20,000 euros. But an air-to-air heat pump perhaps costs 1,500, 2,000 euros, not more than that, and saves you quite a lot. And in Ireland, you don't have these very deep temperatures where the air-to-air heat pump wouldn't work anymore very effectively. -5 degrees is...
What's the difference between an air-to-air heat pump and an air-to-water? I think we have an air-to-water heat pump.
Okay, air-to-air is, of course, utilizing the outside air and taking it through the heat pump, the compressor, and heating air. And you will have this unit perhaps up on the roof here, and it blows air into your home. You will have one point of like blowing air into your home. So if you have an open space solution, it could heat your whole house. But if you have closed rooms, it's difficult to use it, not gonna work. Yeah? But if you have like the ground floor open, like living room, kitchen all open, and then you have an open stairway going up, then it makes sense. Yeah? And air to water is using outside air, the same unit outside, but producing hot water.
We have air-to-water.
Yeah, yeah. And then you can have the ground source heat pump, which utilizes the heat from the ground. These ground source heat pumps work all over the year very well, because the ground is not affected by ambient temperatures. So you always have like this 10 degrees in the ground, and when you use air input from the outside and you drop the temperature to -5, -10, -15 as we have in Sweden, then the air heat pump is not working effectively anymore. Yeah. Yeah, an integrated district heating system with solar thermal and biomass in Sweden, also small scale. Large scale can look like this, an option in Finland or in Germany. This is solar thermal heating for supplying. The district heating systems often have challenges during the summer period. The heat demand is very low, only for hot water, for the houses connected, and then most of the district heating system during summer period are not profitable. But with a combination with solar thermal and also with cheap electricity during the summer period and the hybrid solution, solar thermal and heat pump, can actually improve profitability in a district heating system. And then we have this like still for the future micro CHP, where you produce heat and electricity at your location from natural gas or from gasification. It's still very expensive, and it has still some technical issues, but it's a coming solution. There are different providers, of course, on the market already. And I think we have to watch this space, but it's still too expensive, only with a lot of subsidies, and you can actually think about investing into it. Another nice student project we did just last year was utilizing the energy in wastewater. And this is like a heat exchange pack which you sink into the wastewater tank, and that takes out like 95%. It's very efficient. Heat energy from wastewater from a bigger building or from a sewage plant, and then can be used for heating the premises, the facility. Yeah, and then we have, of course, solar PV with battery banks, large scale. Wind not only has to be large scale, there's also small scale solutions. And I think especially in Ireland, where you have a lot of sites with a lot of wind, even small-scale solutions can be effective. Yeah. So concluding this small presentation before the break, I think it's important to think about small steps, as you mentioned. Okay, energy efficiency also in small steps. Cooperate, share experiences, buy materials together, like insulation for houses, replacing windows, etc. And then utilize the skills in the community. As in this room, I think in every community you will have a lot of craft people who can contribute to, like, instead of buying in expensive services from somewhere. And then measure also and compare. So how much the first small project could be just to measure the energy consumption in the community for a year, for example, and then see, okay, how do we compare with other communities? How do we compare to the building standards? Where does our specific energy use lie? 250 kilowatt hours per square meters per year, or 300, or lower. Yeah. So, and then, of course, the next step is developing further ideas, etc., etc. Okay.